In this video, we are going to look at constant polynomials inside the polynomial ring of r square bracket x. And we're also going to see that the constant polynomials can be thought of as elements of r themselves. And so the upshot is that r can be thought of as a subring of r square bracket x. So to get started, we will let r be a ring. Now, if I take A inside of R, then the polynomial P of x is always equal to A is an element of the ring of polynomials over R. In other words, r square bracket x. As an example to make this clearer about what I mean by the function is identically equal to A, let's think about looking at P of x is equal to 3 inside the ring of polynomials over the real numbers. Now, this function is a function that I know how to graph. I put in a coordinate plane and I go up 1, 2, 3, and I have a line here, and this line is y is equal to 3, and this is the graph of the constant function y is equal to p of x when p of x is identically equal to 3. So inside of r square bracket x, the constant polynomials are just the horizontal lines. In other polynomial rings, for each of the elements inside R, we wind up getting a constant polynomial. Now, it is traditional to write K inside of R and P of x equal to K inside of r square bracket x, but it's also traditional to shorten this as just K inside r square bracket x. And I want to think about what that actually means for just a minute. In other words, if K is inside R, then K can also be thought of as being inside r square bracket x, where this K represents a constant function. In other words, it represents the function P of x is identically equal to K. So what this means is that we can think about R as being a subset of the ring of polynomials over R. And the other thing is what this means is that R is a subring of r square bracket x. Because if you add two things in R together, that's the same as if you are adding two constant functions together, and if you multiply two things in R, that's going to be the same thing as if you're multiplying two constant functions together. So R is always going to be a subring of the ring of polynomials. And that's kind of an important fact, and that's actually why we tend to think about calling R as a base ring, because the essential picture starts to look like this. And so R's down here is the base. Now there's one more thing that I want to think about in this particular video, and that's the degree of constant polynomials. So I want to kind of go back to the definition of the degree of a polynomial. If P of x is inside r square bracket x, the degree of P of x is supposed to be the power of x, not the power, yeah, the power of x in the leading term. So let me write it that way, in the leading term. And the leading term of p of x was equal to a sub n times x to the n, where a n was not equal to 0, and this was the highest power of x in the polynomial. So n is the highest power of x. In the polynomial. So the degree of something like x squared plus 5 is obviously 2, and the degree of x to the 10th is 10, and the degree of something like 3, well, that 3 would be 3 times x to the 0, and there are no other higher powers of x, so the degree of a constant polynomial is going to be 0. But this is only going to be true when the constant is not equal to 0. So let me write this down as since 3 is not equal to 0. In other words, we have this important phenomenon. If I look at k being a constant polynomial in the ring of polynomials over R, and k is not equal to 0, then the degree of that polynomial is going to be 0. But if we look at the 0 polynomial himself as being part of R square bracket x, then the degree of this guy is actually going to be undefined, and he's undefined specifically because the leading coefficient, such as it is equal to 0, but leading coefficients are not supposed to be equal to 0. They're not supposed to be 0 in the definition of degree. In other words, the degree of a polynomial is the highest power of x with a non-zero coefficient. So in something like 3 times x to the 0, we would get a degree being equal to 0 because 3 is not 0. But this definition does not apply to the 0 polynomial itself. The degree of the 0 polynomial is always going to be undefined. And that actually is important for a couple of things that we look at when we're dealing with building certain things inside rings of polynomials.